So far we have seen what is memory and what are the different types of memory, and we have seen the implementation of providing memory to an LLM by using conversation buffer memory and conversation buffer window memory. Now let's see how we can provide an memory to an LLM by using conversation summary memory, right? So let's go to our code editor, VS Code, so we can see the implementation here, right? So we have seen conversation buffer memory, and the second one is conversation buffer window memory, right? Now let's see conversation summary memory, right? So click on memory demo, file, new file, Python file, and let's save it as conversation summary memory demo. The conversation summary memory, as the name suggests, it will try to remember the summary of the conversation and try to answer by using that summary, right? So we can retain the context by summarizing the content. And if we summarize and store, we will be using less number of texts. That means less number of tokens. And we will not lose the context like either conversation buffer memory or conversation buffer window memory, right? Because either in conversation buffer memory, we are trying to store every single conversation here, and with the buffer window memory, we are trying to store at least few number of conversations, right? So we are trying to store the exact conversations, but whereas with conversation summary memory, it will try to summarize the content and will try to answer from the summary, right? So at least conversation summary is better than conversation buffer or conversation buffer window, right? Now let's see the implementation part. So let me copy the same code until LLM initialization, right? So I'm copying the same code, and instead of conversation buffer window memory, we will be using conversation summary memory, right? So here we installed all the required packages, and then we imported the modules, and then here we are trying to load the environment variable and read the API key and store it in environment variable Anthropic API key. Here we are using Anthropic LLM, right? And this is the model we are using. So this is clear so far. So now let's try to create a long string and see if the LLM can summarize the text, right? So this is our text, and we are assigning this to a variable called schedule. And our text says there is a meeting at 8 a.m. with your product team. You will need your PowerPoint presentation prepared. 9 to 12 p.m. have time to work on your LangChain project, which will go quickly because LangChain is such a powerful tool. At noon, lunch at the Italian restaurant with a customer who is driving from over an hour away to meet you to understand the latest in AI. Be sure to bring your laptop to show the latest LLM demo, right? So this is our text. Now, next step is we want to give memory to the LLM, right? By using conversation summary memory. So we used conversation summary memory and we passed the LLM. We already initialized the LLM, and the max token limit is equal to 100. And then inside conversation summary memory, we have a method called save_context, which we have seen already with conversation buffer window memory, right? Memory.saveContext, input is equal to hello, output is equal to WhatsApp. If user says hello, you want the LLM to say as WhatsApp, right? And similarly, let's add one more. Input is not much, just hanging. If the user says this, you want the LLM to say cool, right? Now let's try to add one more. If the user says what is on the schedule today, then you want the LLM to respond from this schedule, right? So the schedule is we have already defined with this text, right? Now let's try to load these variables by using inside conversation summary memory. We have a method called load memory variables, right? So here this schedule, it is a long text, right? And the max token limit is 100. And if you do not specify this limit, then it will take the limit of the LLM, right? We know each LLM has its own maximum token limit, right? So in this case, it is Claude Anthropic. Whatever the token limit is there, it will try to take that one. Otherwise, here we are trying to specify the maximum token limit as 100. So in this case, it will consider 100, right? And inside conversation summary memory, we have a function called save underscore context, right? So inside save underscore context, you can try to save the question answers that do not change, right? For example, let's say you can give the URL for onboarding document, or maybe payslip URL, or your company's 10K report, right? That is what is onboarding URL, and then you specify the URL. And what is the URL for payslip, and here you specify the URL. Or if the user says, how can I download our organization 10K report, then you specify the URL here, right? So for any question, if the answer is not changing, then in that case you can just try to save. You can use save underscore context and try to save that, right? So what we did here, we installed the required packages and then we loaded the modules, we read the key and stored here, and this is how we initialized our Claude Anthropic model, and then we created a long text. This is our long text, and we are using conversation summary memory, and here we are passing our LLM and we are assigning the max token limit as 100, and by using save underscore context we are trying to store these variables, right? This is a dictionary, right? So if the user says hello, we want the LLM to say WhatsApp. Not much, just hanging, then you want the LLM to say cool. What is on the schedule today? Then it has to summarize from this context, right? So now let's try to print this and see. So let's run the code. So now you can see here is the new summary incorporating the additional lines of conversation, right? So what is it trying to say? This is the response from AI, right? So here is the new summary incorporating the additional lines of conversation. The human greets the AI and the AI responds casually, right? So what does that mean? The human says hello, the AI says what's up, right? The human indicates they are not doing much, just hanging out. So this one, and the AI acknowledges this with a brief, cool response, right? The human then asks about the day's schedule, right? So that is what we are trying to ask. The AI provides a detailed itinerary, including an 8 a.m. meeting with the product team requiring a PowerPoint presentation. So that means this schedule, right? So it is trying to summarize this text. Time allocated for working on a LangChain project from 9 to 12, right? So that is what we are doing from 9 to 12, right? And a lunch meeting at an Italian restaurant with a customer interested in AI, right? So that is what we are trying to do at noon. Advising to bring a laptop for an LLM demo, right? So this is our long text, and this is how our Claude Anthropic LLM summarized, right? You can see it summarized the lengthy conversations, right? So here you can replace this text with any other text and see how the LLM is summarizing, right? Now let's try to use this conversation chain. So let me minimize this. So now by using this conversation chain, let's try to bind both memory and LLM, right? Which we have seen already. So use the conversation chain for memory, assign memory variable, and for LLM we have already initialized, so assign that and verbose is equal to true, right? So once we have the conversation chain ready, let's try to ask another question by using predict, and here we are trying to pass 9 to 12, what will you do, right? So it should answer based on the summary from the long text, right, which is stored inside schedule variable, and we have already seen it already summarized, right? So now let's see if the LLM will be able to answer for this question from this summary, right? So now let's rerun the code. So you can see the current conversation, and this is the updated summary. Then human, we asked 9 to 12 p.m. what will you do, right? So that is our question. And what is the response from AI? According to the summary provided, from 9 to 12, I will be working on a LangChain project, right? So that is what we have provided here. 9 to 12 p.m. have time to work on your LangChain project, right? And it's trying to give more information here. It's a substantial 3-hour block of time dedicated to this task, right? So for our question 9 to 12, what will you do? This is what our LLM is trying to respond, right? So the LLM was able to answer the question from the summary, right? So it summarized first, and then from this summary it tried to answer the question that we asked, right? Okay, so now let's try to ask more questions, right? So let's ask, what is deep learning, right? Now let's run the code. So you can see the answer from the LLM, right? Now let's try to ask one other question, right? What is AI? And then now let's try to, or let me kill this terminal, and then let me try to rerun the code. So let me scroll up. So if you notice here, this is the conversation, right? And then it tried to summarize, and then we asked a question and the AI responded. And then again we asked another question, what is deep learning? Here it tried to summarize about deep learning. And then if you scroll down, we asked, what is AI? Before this, it says the human then asks about deep learning, right? So what it did, it tried to summarize here, right? That is the advantage of using conversation summary memory, right? So for every single conversation, it is trying to summarize and try to append it to the answer, right? And the next question is, we asked what is AI, and then it tried to provide the answer. And if you ask one other question, then it will try to summarize the previous conversations as well, right? So by using this conversation summary memory, the conversation will be summarized and stored instead of the entire response, right? So that means it indicates less text, right? Which is nothing but less tokens. So this conversation summary memory, this is better than conversation buffer memory or conversation buffer window memory, right? Because in these two cases, we have seen it is trying to store every single conversation entire context, right? But whereas with conversation summary memory, the LLM is trying to summarize and then store, right? So that means less text, so less tokens, right? Even by using conversation summary memory, let's say if you keep asking more questions, it may fail at some point because we know each LLM has context window or token limitation, right? Here we specified the max token limit as 100. Once it uses all the tokens, then it may not be able to answer any further, right? But at least this conversation summary memory is better than the other two types that we have seen. So that's all about memory. So we have seen conversation buffer memory and conversation buffer window memory and conversation summary memory. You can try exploring other memories depending on your requirement, right? But you get the idea of memory, right? Memory is nothing but trying to give power to the LLM so that the LLM can remember the context, right? Now, if you want, you can deep dive other memory types which we have inside this LangChain, right? So LangChain supports these other memory types as well. So this is the official documentation, and depending on your requirement, you can try to deep dive, right? All right. That's all about memory. Thank you.